Welcome to Where is Truth? My name is Norman Peckham, and I have with me Dr. Ariel Roth, scientist, geologist. We're so glad that you can be here with us. This begins a short series of lectures having to do with the fossil record. Scientists have one view of the fossil record. Creationists wonder what on earth to do with the fossil record. So let's examine some of those issues, but begin with what is the fossil record?
Well, the fossil record refers to the different kinds of fossils at different levels. You got a picture here, a number of layers here from Dead Horse Point in Utah, and some layers have no fossils. Most of them have a few, but we find that fossils are not all mixed up. As you look through that record, you find certain kind of fossils at certain levels, others at different levels, and so on. There are some fossils that are the same all the way through the fossil record, but in general, there's some difference between them. And that's the fossil record. We refer to those differences in those different layers as we look at these fossils all over the world.
So with these different fossils in different layers, that provides opportunity for some interpretation. So how are they interpreted?
Well, you know, there are two strongly contrasting views that we're dealing with here. First, the traditional scientific interpretation is that fossil represents gradual evolution over billions of years. In contrast to that, we have the interpretation that the fossil represents burial by the Genesis flood just a few thousand years ago. Extreme time contrast between these two, and extreme difference in interpretation of the meaning. To the creationists, the fossil record means mainly the effects of the Genesis flood, rapid burial. To the evolutionists, it means gradual evolution over very long periods of time.
Well, let's look at some of the evidence that both of those groups are looking at.
Well, yeah, and to do that, let's just have a brief introduction to the fossil record. Now, this slide may discourage you just a little bit, but we're just going to deal with the main parts here. In the upper left-hand corner, you see kind of a bluish area. That's part of those layers out there as they go from top to bottom. And that represents the part called the Phanerozoic, where we have mostly all our main well-known organisms, large fossils, and so on. Okay. You go below that, you have kind of a brownish Precambrian area. Those are microscopic organisms, mainly.
No big fossils down there?
Hardly.
Very few.
Hardly any. It'll help us if you'll keep in mind that blue region, just go to the right of it. The top region is called the Cenozoic. That's the highest region, and then in the middle you got a greenish Mesozoic, and below that you got a rusty red Paleozoic. Those are the three main divisions, and we'll be dealing with these as we consider the fossil record. So kind of keep in mind that the way it's divided here. A lot of careful work has been done by paleontologists on this and so on. Interpretations vary, but there's been a lot of good scientific work done in working on this fossil record. When you go to the Grand Canyon, for instance, you see this red arrow down there on the left side.
Yes.
That's the main division we're telling you about. Below that, scarce microscopic organism in general. Above that, fairly abundant, larger kinds of organisms, both plants and animals and so on, crabs and other things that we're familiar with. And so on. So there's a major difference right there at that point, and it's called the Cambrian explosion. We'll refer to that a little bit later as we look at various kinds of fossils.
Well, so what kind of fossils do we start with then?
Let's look at fossils starting from the bottom going up according to the evolutionary interpretation, and this is what has been published and considered as the oldest living fossil that's ever been found. It's supposed to be 3,465 million years old.
Oh, is that everybody agrees on that in the scientific community?
Well, no, but in general, they say it's very old.
Okay.
But after samples of this were sent all over the world, a number of scientists looked at this and they said, hey, this is not a real fossil. Because they found material just like this that didn't seem to be, it was in the same region, but it didn't seem to have any cellular structure per se and so on. And they think it's just an accident this happened to look a little bit like living stuff. So it's what you'd call a pseudo-fossil. Now, it's a false fossil.
Okay, something that looked like a fossil but didn't turn out to be one.
Right.
Okay.
But still, in some of these very deep layers, you can find some very good fossils. This is supposed to be 2,000 million years old. And it was an algae. And they look just like modern algae, these organisms. Very well preserved algae that you find there. Then we have also stromatolites. These are layers, and right at the end of the arrow, the red arrow, you notice some layers there. Supposed to have been laid down by algae or other microbial organisms were trapping sediment and so on, so they gradually built up. Stromatolites are controversial. But this is part of some of the fossils and the simple organisms we find in the Precambrian. Now, as soon as we jump across that Cambrian explosion thing, then we find some organisms we're a little more familiar with, although you probably have never seen a live one of these because they've been extinct for quite a while. But this is a trilobite here, and it's, we're in the Paleozoic, the lowest division of those three main divisions we were telling you about of the Phanerozoic. And here's a nautiloid right at the end of that red arrow.
Is that like a chambered nautilus?
Yeah, very closely related to it.
Pretty complex animal.
Yes, yes. And you're in the Paleozoic here in this region. This happens to be a sample from the Grand Canyon. And here's a fossil tree from Nova Scotia. Look at the end of the tip of the red arrow there, and you see an upright tree there in the layers. And my hand is down there pointing to the root down at the bottom. So again, we're still here in the Paleozoic, but these are part of the trees that help produce much of our coal in the eastern part of the United States.
I see.
And, now we're in the Mesozoic, and this is a dinosaur track.
Up a little higher in the column?
A little higher in the column. And of course, dinosaurs, everybody seems interested in them, so Tyrannosaurus rex has to be mentioned here. That's in the Mesozoic. And you can note the person there below the dinosaur there for scale, so you get some idea. This is one of the larger specimens, of course.
It's kind of an appetizer there.
Yeah, well, you could think of it that way. And then we have dinosaur eggs here, again, still in the Mesozoic. And coal. This is coal in the western part of the United States. It's usually higher up in the geologic column. But those black layers you see there, evidence of past life. This is a genuine, all those black layers here are genuine forms of fossils. And then we have huge ammonites like this. Some of our fossils are much larger than the contemporary organisms we have now. And this is an example. This is represents something like a chambered nautilus. As you know, our chambered nautilus, runs 6, 8 inches in diameter. This is about 6 feet in diameter. Wow. It's found in Germany. And then we get into the Cenozoic. Here's the fish, although there are fish all the way down in the Phanerozoic, but this is a fish from the Green River, from the black part that you see there, the black, and a tree at the end of the arrow there. You see a fossil tree there, and we have mammals in the Cenozoic. We're up in this top region, the Cenozoic. This is a giant sloth. These things are 20 feet long, huge animals, not existing anymore at present, but evidence so we've kind of gone up.
We've seen that kind of layering then, the organization, the one-celled creatures, and then appears to get more complex, and ultimately with this, so now we have the data, and now we need to interpret how that data got there.
Yes.
How did it happen?
Well, there are several interpretations. Let's look first at the evolutionary view.
Okay.
They feel this series of fossils, as you go up through this fossil record, represents gradual evolution over long time and so on. That it depends billions of years, and this is in contrast to the creation model where you talk about a flood and so on.
So the organisms over billions of years got more complex, yes, got buried and more complex, and created the fossil record via that mechanism.
That's right. Here's a picture. It shows you these are the kind of organisms you'd find in these various layers. You have first at the bottom those microscopic organisms, and then you have the Paleozoic section there, which is the kind of the middle section we have in this diagram. But anyway, you got mostly marine organisms down at the bottom, practically all marine organisms actually. But higher up in that you have some salamanders, fish, and so on, some plants actually. Then you get into the next section above, the Mesozoic. You can see from the labels at the left. There you've got dinosaurs and so on. Reptiles tend to dominate. You got some mammals down in there, but not very many. And then at the top layer, you got mammals of various kinds, whales. You got a man there at his desk in that particular part. So. And evolutionists look at this and they say, hey, this represents gradual evolution.
Well, if you were to believe in the evolutionary model, this certainly would be evidence that you would present to support that.
Well, it certainly looks like that.
That's right.
If you don't look at some of the observed problems that we'll consider later on.
Oh, okay. So what do then creationists do with this progression? How do they account for this kind of look in the fossil record?
Well, they feel this represents what happened during the flood.
Oh.
And the fossil record represents the way animals are buried during the flood, and that various mechanisms were involved in this. We'll talk about a couple of them here, 3 of them in fact. And conditions before the flood were different than we have at present. There was a different set of organisms there, and because of that, we have a different kind of fossil record.
Okay.
And you know, face it, the fossil record is a lot of organisms in there that are not living at present.
Yeah.
Take dinosaurs, for instance.
Exactly.
And many different kinds of plants that don't live at present in the fossil record, and so on. So the suggestion is that the distribution of organisms, one of them, one idea at least, there's several ideas here. One idea is that the distribution we see in the fossil reflects the distribution of organisms before the flood. We're probably aware that, at least most people are aware that, as you change altitude when you're traveling up and down through mountains and so on, the vegetation changes and the kinds of animals we have there change. And this is a mountain in eastern France, and you can see a lot of large trees down at the bottom, and higher up you have brush or smaller trees and so on, and pretty soon you have no trees at all. Well, if you have this kind of an arrangement, is it possible that before the flood, organisms were also distributed this way and buried in order, and that's why we find the sequence in the fossil record. This is this ecological zonation theory. Here's a picture of the various ecological realms that we have now at present, including oceans. Down at the left-hand side, oceans, and then different kinds of trees and plants as you're going up the mountain towards the right. Well, if we had a flood burying this, and it started by the fountains of the deep, as the Bible describes, fountains of deep breaking up, the first thing you would destroy is the marine material down below. And
so we'll be the first thing buried.
Right.
Okay.
And you see purple arrow here shows you what would happen. Material from the marine realms or environments is taken and buried and forms the lowest layer.
Okay.
Now, if your floodwaters rise into the lowlands, as you'd expect from a worldwide flood, those organisms living at that level would be buried next, and the red arrow shows you they'd be laid on top of the purple ones. The marine organisms are represented by the purple arrow. And then if you went up a little higher up, another set of organisms would be eroded away along with the sediments and so on, and produce another layer illustrated by the yellow arrow, and then you go up higher up yet, and still a different set of organisms. This illustrates how the sequence that we find in the fossil represents the sequence of the altitudinal changes of organisms as they lived before the flood.
Which would give us the organization that we see in the fossil record now.
Right, exactly. The waters, the waves of the flood would be the destructive factor, not the rain so much.
Yes.
This is a picture of some waves here. I was in the rain when I took this picture on the coast of Hawaii, and the rain didn't wash me away. If I'd gotten in that wave, I'd have been washed away. It illustrates it.
You might have been a fossil.
Yes. The important thing is the wave activity,
sure,
and so on. Well, this is an illustration of what we think maybe, according to this idea, ecological zonation, how the organisms may have been distributed before the flood. And you can see your geologic column to the left there, the Cenozoic, Mesozoic, Paleozoic, so on, and then the Precambrian below it. This blue arrow points to that region. That's where you find microorganisms. They're living there now. They could be fossilized before the flood, during the flood, after the flood. And we find those kind of fossils there. Above that, we have this major C here at the end of the purple arrow there, and that's where the marine material would be.
That's that lower layers that we were talking about.
Then you go up a little higher, and then we start making some land fossils and so on. And when those are washed on top of the marine layers, we get land type of organisms. Then you go a little higher, and you have the Mesozoic organisms, different trees and plants and so on than we have at present mostly. And dinosaurs, reptiles of various kinds. Reptiles dominated in that region and so on. And then on top we would have the mammals living higher up in the higher regions, and that is the Cenozoic. Now, if you take that sequence and bury it the way it is there, you have the sequence that we find in the fossil record. Evolutionists interpret that, well, a gradual evolution and so on, but it could be that it reflects the distribution. In fact, some of the data fits the creation model pretty well, and just let me mention 4 factors that seem to fit nicely with this idea. One, the microscopic organisms below, that's what you'd expect. The Cambrian explosion, that's where you have those first marine layers. Then we hit into land animals above that, and that's where we have the lowest continent, land material on the continents before the flood. And then you have a moderate increase in complexity through this sequence. It is not the same distribution we have now, but we are dealing with a different set of organisms that would have a different ecological relationship, and competition would be different, and so on. So this slide illustrates some of those factors I just mentioned there. The red line there is your Cambrian explode. It's the bottom of your seas, and you have microscopic organisms below. Then you have all these marine organisms. There are sponges, you know, and some fish-like organisms, brachiopods, and so on, above it, but no terrestrial organisms till you get to that blue line. The blue line above there. Then you have terrestrial organisms. You got amphibians of various kinds in there, and then higher up you have the reptiles and the mammals at the top. So you have somewhat of an increase in sequence here, but you have rather striking features that, you know, fit nicely with what we would expect in terms of the way organisms live at present. There's another idea, and that is that motility, the ability to move, may have affected the distribution of organisms during this worldwide flood. And this snowy egret here flying away illustrates how birds can escape. And the fossil record has been notoriously known for the absence or the rarity of fossil birds. Now there are some, they found some in fossils in China recently and so on, but still in general, birds are hard to find in the fossil record. And it may be that they escaped and so on. The interesting thing is that at times we find tracks for these animals at various levels, but we don't find the bodies of the animals till higher up. For instance, trilobites that I mentioned earlier, we find the tracks of trilobites below where we find the trilobites. Birds, we found bird tracks quite a ways down below where we expect to find them in the fossil record. Of course, evolution say, well, maybe those aren't really bird tracks type of thing. And then we found tetrapods, some kind of tetrapod, an animal four-footed, long before we find any tetrapod fossils. I shouldn't say long, but a while before we find, below where we find a good tetrapod
But
fossil.
in the context of a worldwide flood, a creature making tracks, getting away, and then those tracks being fossilized is perfectly logical.
Yeah. So that kind of data that suggests, you know, that maybe there's something to this motility factor.
Right.
There's a Cope's rule that in evolutionary thinking that says that larger, you go up the fossil record and the animals get larger. That doesn't apply at all, everywhere at all, as we mentioned. But that could be a motility factor involved in that type of thing. So. Well, another idea is the buoyancy, the ability to float carcasses. There's a picture right at the end of the arrow of a pond, and there's a dead bird there, and I'm glad you can't see it very well because it's not a pleasant picture, but it's floating there.
In today's world, we have man down floating around doing scuba diving down in the very low layers and climbing the mountains. He's found at all layers. Why is he not found in all layers here?
Well, that is a very interesting question. I'll get to it in just a minute. Let me just mention in connection with this that the length of time that animals' carcasses float fits pretty well with the length of time during the flood. We're talking about 76 days on average for birds, clear on down to 5 days for amphibians and so on. So the suggestion that might be involved here, but getting to your question there, it is a fact that we have not found good examples of man except in the higher layers in the Cenozoic and so on. This picture here shows you the red arrow there pointing to man. That's where he is. And while there have been some reports of man lower down and so on, we don't know of any that's really valid, or that doesn't represent perhaps some infiltration by man that is reinterpreted and so on. So man is just there. And this is an interesting question. Why? I'll give you four different answers here. One, it could be that before the flood, not that many humans were present. Noah had only 3 sons in 600 years. They weren't reproducing as fast as we're reproducing now. Or the second idea is that during the flood, man escaped to the higher regions, and if you're up on top of something, you're not going to get buried and preserved.
Right.
Third one is that man lived up in those higher regions, maybe with the other mammals and so on. Maybe it's warmer in the other regions. And that's where he was to start out with. Or lastly, I'd suggest flood activity could have destroyed the evidence for this type of thing.
We have looked at the reality of a geologic column that has some organization to it. If you believe in evolution, you can look at that organization and it will provide evidence for your belief. We've also seen, though, that we could come to this same organization, look at it from the standpoint of ecological zoning, of organisms living in different zones that would be buried at different times, that would provide that same organization. And so creationists really don't have to take a back seat to scientific interpretation. Now, none of us were there. So we really can't say for sure it happened this way, or for sure it happened this, then other way, on the basis of the record that we look at. We'd have to bring other data for that. So don't go away. We'll be back when we look for Where is Truth. If you would like additional free information about these discussions, there is a PowerPoint resource available on the internet that covers many more details than could be provided in this lecture series. The resource is titled The Bible and Science and is available at scienceandscriptures.com. Be sure to add an S at the end of the word Scriptures to get to the right web page. The Bible and Science resource follows the same sequence of topics as the Where is Truth series, but it is divided into 17 separate discussions instead of the 14 videos of the Where is Truth series. The title of the discussions, an introductory outline, and an index will lead you to the topics you want. The Bible and Science discussions served as the resource for the Where is Truth videos.